Today we're going to learn a new method for solving a system of linear equations. The book calls it the adding or subtracting method or the elimination method, and the elimination method is the name I prefer. Now, in a lot of cases it can be quicker than the substitution method, but it really depends on how you approach it and what you are given to begin with. So if we have two equations, 2x plus 3y equals 11, and negative 2x plus 5y equals 13. We can see that it would be a bit cumbersome to use the substitution method because we'd have to solve one of the equations for x or y, which is going to involve some rearranging and some dividing, and we're going to end up with a lot of messy fractions. What I want you to notice is that these two x terms have opposite coefficients. One is 2, the other is negative 2, and that's going to be a real good indication that we're going to want to use elimination. Basically, with elimination, what we do is we either add or subtract the two fractions, and it will, if we do it right, we'll be able to eliminate one of the variables. In this case, when I add these two equations, I'm basically adding everything on the left-hand sides first, and then everything on the right-hand sides. When I add everything on the left-hand sides, 2x and negative 2x add up to 0. They eliminate each other. 3y and 5y give me 8y. And on the right hand side, 11 and 13 add up to 24. Then, it's a simple step to divide by 8 and get y equals 3. Now, we kind of go back to substitution in order to find the x value that goes with that y value. So I pick one of my equations and I put 3 in for y. And I solve for x. So 2x plus 9 equals 11. 2x would have to equal 2, so x would equal 1, giving me a final solution of 1, 3. And just like when I was solving these by substitution, I can check my answer by plugging it back into both equations and making sure that it works for both equations, that it's a point on both of the lines. So that's elimination in a nutshell, but we're going to have different things arise that change our approach. For instance, the next set of equations we're given has matching y coefficients, but they're not opposites. So we see that I have 3y in both equations. Now there's two basic tactics you can take. Instead of adding the equations, you can subtract them. Or what you could do is you can multiply one of the equations by negative. Let's just subtract, and we'll save multiplying for the next lesson. So when I subtract, I'm subtracting the left-hand side. 4x minus 5x gives me negative 1x, or just negative x. 3y minus 3y goes away, becomes 0. And here's where I have to be careful. 2 minus negative 2 is positive 4, because a positive minus a negative is just like adding two positives. So I get negative x equals 4, which means that positive x equals negative 4. And I find y the same way I found it in every other equation. I plug it into one of my equations for x. So negative 16 plus 3y equals 2. Adding 16 to both sides gives me 3y equals 18. Dividing by 3 tells me that y equals 6. So my solution is negative 4, 6. And again, I could check that by plugging it into both equations and making sure it works. The other issue that might come up is our equations might be a little out of order. For instance, if we had 8x minus 4y equals negative 4, and 4y equals 3x plus 14. Now we want to rearrange it so it looks like it did in our last two examples, so that we have x's and y's on both sides, or x's and y's on the same side. So I'm going to move this 3x over to the other side by subtracting it because it's a positive 3x. So now I'll have negative 3x, positive 4y equaling 14. And I'm going to rewrite my original equation so I can see them better when I go to add them. Now when I add my equations, everything is lined up nicely. So negative 3x and 8x is 5x. 4y and negative 4y is 0. 14 and negative 4 is 10. So dividing by 5 gives me x equals 2. So when I'm using elimination, I want everything in the same order. So I want my x's and y's on the same side. Now that I have x equals 2, I can plug it into any one of the equations that I want. I could even plug it into this one that I rearranged, which might be helpful in some cases. Because 4y equals 3 times 2 plus 14. 3 times 2 is 6, plus 14 is 20, and dividing by 4 gives us y equals 5. So I might be a little quicker that way than plugging it into one of the other equations, but do whichever works best for you. As long as you get the right answer, your method doesn't have to be exactly like mine. Now I'm going to give you a chance to try your own. I'll give you a pair of equations and see how you do. 2x plus 5y equals 12, and 5y equals 4x plus 6. Take a few minutes, see if you can find the solution of those systems of equations, and of that system of equation, and unpause the video and see how you did. Okay, remember our first step is to rearrange the order of the second one so you get x and y on the same side. So we're going to subtract 4x from both sides, and our new equation becomes negative 4x plus 5y equals 6. Then I want to rewrite my first equation, make it easier to see everything. Now, since those 5y's have the same sign, I have to subtract in order to eliminate them. So negative 4x minus 2x gives me negative 6x. 5y minus 5y is 0, and 6 minus 12 is negative 6. If I divide both sides by negative 6, I get x equals positive 1. Now I can plug that back into one of my original equations to solve for y. Now I'm going to do it a little differently than I did last time just to show you that it works regardless of which equation you plug it into. So we'll plug 1 in to the first equation. 2 times 1 plus 5y equals 12, which means that 2 plus 5y equals 12. So 5y must equal 10, which means y equals 2. So our solution is 1, 2. And again, we can check that by plugging it in to both of the equations that we had to start with and making sure it worked. Let's try a word problem. During a kayaking trip, a kayaker travels 12 miles upstream against the current and 12 miles downstream. I'm going to write that down. 12 miles upstream and 12 miles downstream. So when he's going upstream, he's going against the current. The current is working against him. When he's going downstream, the current is working with him. It's pushing him along. The speed of the current remained constant during the trip. Find the average speed of the kayak in still water and the speed of the current if his upstream time was 3 hours and his downstream time was 2 hours. Now here's what we have to understand. When he's kayaking upstream, the speed of the boat minus the speed of the current gives us his actual speed. This is his total speed upstream. For instance, if you were kayaking at 5 miles per hour, but the current was moving at 2 miles per hour, that means you only gain 3 miles per hour. Now, when you're going downstream, you add the speed of the current because that helps you along. So if you were still kayaking at a speed of 5 miles per hour and the current was going 2 miles an hour, that would get you 7 miles every hour. So let's look at this. The distance that he traveled upstream was 12 miles. And we know that distance equals rate times time. Now the time it took him to go upstream was 3 hours. And we're going to multiply that by the speed of his boat minus the speed of the current. Downstream took him 2 hours. We're multiplying that by B plus C. So the time he spent going upstream was 3 hours times his speed gives us 12 miles, his total distance. And then downstream was 2 hours times his speed, which gives us 12 miles. Now, to save us a little bit of work, instead of using the distributive property, what I'm going to do is I'm going to divide both sides of each equation by 3 and 2 respectively. Because if 3 times b minus c equals 12, then b minus c has to equal 4. If he's traveling 12 miles in 3 hours, that means his total speed is 4 miles per hour. And then downstream, if he's traveling 12 miles in 2 hours, that means he's traveling 6 miles per hour for B plus C. So now we can use elimination to find the speed of the boat and the speed of the current. Now notice, because their coefficients match, I can either add, which will eliminate the C's, or I can subtract, which will eliminate the B's. Now I find that when I subtract, I tend to make more mistakes. So I'm going to add the two equations and eliminate the C's. Okay, so when I add my equations, I get 2b on the left. The C's eliminate each other, and I get 10 miles per hour on the right. Dividing both sides by 2 tells me that my boat is moving 5 miles per hour by itself. Now, if the boat was moving 5 miles per hour and the current brought it down to 4 miles per hour, then the speed of the current must have been 1 mile per hour. Okay, which would also mean that if it's moving 5 miles per hour and I'm going downstream, that would bring it up to 6 miles per hour. So there's the speed of the boat and the current. All right, if you have any questions, feel free to ask. If not, you can get started on your homework.